Let's look at a scenario wherein dipole is in non-uniform electrical field. First thing is, what is non-uniform about this electrical field? So what it means is, if I have a charge, say over here, the same charge over here, the same charge over here, in this space, in this field, it will experience different force. It can be in terms of magnitude or in terms of direction as well, or both, right? Now, in exam, what is that we have to write? We have to write that in a non-uniform electrical field, that dipole will experience not only torque, but also net force. The net force happens because the two charges can experience opposite but not equal force, right? While the torque will be dependent on where the dipole is. That is, of course, this won't change, while your electrical field will be, yes, position dependent. Does it make sense? Position dependent. That's all. That's all you have to understand. We just have to know the obvious. The two specific cases that they have introduced. One is a scenario wherein we have the dipole to be parallel to the electrical field. That is, theta is equal to 0 degree. That is, your P and E are in same direction. So let's look at this. Say this is your electrical field, and say this is positive and your negative has to be to the left. Reason being, this will be your direction of dipole moment in the direction of your electrical field. So this toe has to be in the same direction. Then we have your parallel scenario. Now the question is, will it move? Yes. Will it rotate? No. Why will it not rotate? Let me write it over here. Torque sine of 0 is 0, and so from this we can infer that torque will be 0. Agree? Sine of 0 is, it has to be 0. I mean, it is 0, not it has to be, it is 0. Now, will it move? I told yes, but in what direction? Well, it depends. Depends on what? Well, it depends on the direction of increasing electrical field. If the direction of increasing electrical field is to the right, then your net force will be to the right. Now the question is why? Why is that I'm telling net force is to the right? Well, actually, we can analyze with the help of the diagram. So plus Q is at a stronger space, right? Let me write it in different layer. This is at a stronger electrical field, and this is of course weaker electrical field. This implies more force. Do you guys agree? So this will experience more force than this. Sorry, my bad. This has to be a push force, because positive charges will experience a push force in the direction of electrical field, while your negative charge will experience a pull force opposite direction of electrical field. Because the push is more than pull, the net force is to the right, and so the movement will be to the right. Okay, does it make sense? Again, I'll repeat, this is where people get confused. We have the electrical field to the right, and the direction of increasing electric field is also to the right. Again, we are assuming. Since we are looking at parallel scenario, positive has to be to the right while the negative is to the left. Or the actual way of telling this is positive charge is to be in the direction of electrical field, because dipole moment is to be in the direction of electrical field. So this orientation has to be so. Now we are assuming that the direction of increasing electrical field, we are assuming that. So positive charge is exposed to a stronger electrical field than negative charge. Till here it's quite clear. Now you have to go back to the basics. Electrical field points in direction of how a positive charge will experience a force. So indirectly we are trying to tell that the positive charge, or directly we are trying to tell that the positive charge will experience a push force while the negative charge will experience a pull force. Because the push is stronger than the pull, obviously it will move in the direction of the push. Right? Again, think step by step, explain it to someone step by step, then you will understand. Here, this is opposite scenario. So we are looking at, say this is your, actually, let me do it this way. So we are looking at the electrical field to be at an angle 180 degree. Now, this is, sorry, this is positive and other end will be negative, right? So this is positive and this is negative, because dipole moment is to the left and your electrical field is to the right. It makes it anti-parallel. Now, if the direction of increasing electrical field, is to the right, then the net force will be not right again. Here it's not so. Think about it. Here, which will experience more electrical field? Yes, this will experience a stronger electrical field. But negative charge will experience what? A push or a pull? It will experience a pull. While the positive charge will experience a push in the direction of the electrical field. Because the pull is a lot more, the net field will be to the left. And so the movement will be also to the left. So it's as simple as that. Okay, it makes sense. So whatever torque though, end of it torque, we have sine of 180 degrees 0. And so torque will be also equal to 0. Again, understand it in detail. It's quite simple. Explain it to someone. That's the best thing that you guys can do.